We're going to find dy dx given x to the 8th minus 5x times y to the 3rd. Ooh, we have a tricky part here. We have a first and a second. We have x's times y's. Anytime we have multiplication, we're going to use the product rule for taking that derivative. So just a quick reminder, product rule, we're going to do derivative of the first, original second, plus derivative of the second times the original first. So tricky problem here. We have x to the 8th, but then that minus 5x times y cubed, we're going to have to use the product rule, plus y to the 4th equals 13. So we're going to start by taking the derivative of both sides with respect to x, which means we are only going to put a dy dx next to a derivative of a y term. So starting with x to the 8th, bringing down that power, we have a derivative of 8, x to the 7th, when we subtract 1 from the new power. And now I'm going to have to be super careful on this product rule. I'm going to put a dy dx if I take the derivative of y cubed, but I'm not going to put a dy dx if I'm taking the derivative of negative 5x. So part of this product rule is going to require dy dx because we're going to take the derivative of a y term, and other part is not because it isn't a derivative of a y term. So when I start out with the derivative of the first factor, derivative of negative 5x, that's the derivative of an x term. It does not require dy dx. Derivative of negative 5x is just negative 5. There's my derivative of the first times the original second is a y cubed. Next part of the product rule is always a plus. Now we're going to do the derivative of the second factor. That second factor has a y term. So we're going to need a dy dx. The derivative of y cubed would be 3y squared. And we need a dy dx. I'm going to actually move it all the way over to the right. We are used to solving for things on the right. Like when we solve for x, we don't usually write x5, we write 5x. So I'm going to keep that dy dx to the right at all times. So derivative of y cubed, my second factor, is 3y squared dy dx. And that needs to be multiplied, that derivative of the second needs to be multiplied with the original first. So the original first here is a negative 5x. All right, let's walk through that product rule one more time before we move on. I don't want to have made a mistake. So we have the derivative of the first. Derivative of negative 5x is negative 5. The original second is a y cubed. I did not take the derivative of a y term, so I don't need a dy dx. That looks great. And now derivative of the second factor, derivative of y cubed is 3y squared dy dx. And the original first is a negative 5x, and I remembered to multiply that in there. So that looks great. So we are ready to continue with our derivative. We're going to take the derivative of y to the 4th, which is 4y cubed. We need a dy dx. And the right-hand side is a nice, fast derivative. The derivative of 13 is 0. Now, I want to solve for dy dx, but I do have some multiplication to tackle here before I even try to combine like terms. So I'm just going to take a second and multiply those together. So you have 8x to the 7th minus 5y cubed. And then I have 3 times negative 5, which is going to give me a negative 15, and I have an x and a y squared. Order doesn't really matter, but typically in math we go alphabetically, so x is before y's. But I really just want to make sure I multiply that 3 times negative 5. That way when I go to combine like terms, I know whether I should add or subtract to move something. So 3 times negative 5 is negative 15, x y squared dy dx, plus 4y cubed dy dx. That's why I like to check the product rule right away, because once we multiply it together, it's a little bit tricky to tell where the derivative came from and check the derivative from there. So now I'm going to combine like terms. I want to solve for dy dx, which means I need to have them on one side by themselves. I can either keep it on the left or move it to the right. This time I will keep the dy dx on the left. So anything without a dy dx, I'm going to move it to the right. So should I keep or move the first term? I should move it. So I'm going to have on the right-hand side a negative 8x to the 7th. There was a 0 over there. I don't really need to write that though. So I'm going to subtract that over, and then I'm going to add 5y cubed. That also needs to be moved. It doesn't have a dy dx. And then I have a negative 15xy squared dy dx that has a dy dx, so it's going to stay on that left side. Negative 15xy squared dy dx. And then same thing, that 4y cubed dy dx is going to stay on the left because it has a dy dx. After we combine like terms, we have all the dy dx's on one side, but the dy dx is not by itself. I always like to put a star on this step. We need to factor to get it by itself. So I'm going to pull out that dy dx. Nobody likes factoring, but this is like the nicest factoring. Those coefficients just go inside the parentheses here. Dy dx was multiplied with a negative 15xy squared and a plus 4y cubed. Equals negative 8x to the 7th plus 5y cubed. And my last step to get dy dx by itself, it's multiplied with this coefficient. I want to get rid of multiplication, which I can do division. So I have to divide by negative 15xy squared plus 4y cubed. And there is my final answer for what dy dx is by itself. Negative 8x to the 7th plus 5y cubed over negative 15xy squared plus 4y cubed.